This is our Pre-Calc technology project by Jason, Alex, and Owen. The plan for an outdoor stadium consists of a rectangular region with a semicircle on each end. The perimeter is a 1,000-foot running track. So this is a three-step problem. For step A is write a function that models the area of the stadium as a function of the diameter of the semicircles. Step B is what is the maximum area possible of the stadium. And step C is for what values of the radius will the area of the stadium be at least 60,000 feet squared. This is a diagram of the problem. So the given information is the perimeter of the track is 1,000 feet. And since we are solving for the area of the stadium in terms of diameter, your independent variable will be diameter, and your dependent variables will be the area and the length of the stadium. For this problem, we will need three equations. Those three are area of a square is equal to length times width. The area of a circle is equal to pi r squared, and the perimeter of the stadium is equal to 2L plus pi d. The 2L represents the two lengths of the stadium, and the pi d represents the circumference of the two semicircles. So for step 1 of the problem, we must write a function that models the area of the stadium as a function of the diameter of the semicircles. For step 1, to do this is find the length of the stadium in terms of diameter using the perimeter formula and the given perimeter of the stadium. So this is done on the left side, where we set the perimeter of the stadium equation equal to 1,000 because that is the given perimeter. We isolate L onto one side, so L is equal to 1,000 minus pi times diameter divided by 2. So we know what L equals. And for step 2 of this, we, using the formulas area of a circle and area of a rectangle, form an equation that will equal the area of the stadium. That is done in blue on the left side of the work. It is area equals length times diameter plus pi times diameter divided by 2 squared. Since that has two variables in it, we must get rid of one or replace one. And since we already know what L equals, we can substitute the equation that we solved in step 1 for L. So the area of the stadium in terms of diameter is equal to 1,000 minus pi times diameter divided by 2 times diameter plus pi times diameter divided by 2 squared. Question 2. What is the maximum area possible of the stadium? For this, we'll use a calculator. So first, to find the maximum area, first you must plug in the equation that we got in question 1 into the y equals button. It's at the top left of the calculator. And since this is a very large number, we will need to reset the window that the graph will be shown. So if you click window, which is right next to y equals, you set the windows to the windows that are given on the left, where the x minimum is equal to -10 and the x maximum is equal to 800. This is so you can see the entire y-axis and the entire parabola. And the y minimum will be equal to -10 and the y maximum is equal to 100,000. This is so you can see the x-axis and all the way to the peak of the parabola. Both scales can remain 1 just to keep it easy. So now you have your windows set, you can go to second trace and then select maximum. It will bring you to the graph of the parabola. First you need to put your cursor on the left side of the maximum peak and hit enter. Then scroll to the right side of the maximum peak of the parabola and hit enter again. Hit enter one more time and it will give you an x and y coordinate of the maximum point at the parabola. The y coordinate represents the maximum area, which is 79,577.47 feet squared, and the diameter is the x, which is 318.31 feet. So that is the answer to question 2. Then question 3, for what values of the radius will the area of the stadium be at least 60,000 feet squared? So for this problem, we must set the equation area of the stadium, which we got in step 1, equal to 60,000. And then simplify the equation and make sure it is equal to 0. So once it's equal to 0, you should have a quadratic equation. Plug the values into a quadratic formula because they do not factor. That is shown on the work on the left side. Once you have your quadratic formula, you can plug that into the calculator and you should get that diameter is either equal to 476.2 feet or 160.43 feet when the area of the stadium is at least 60,000 feet squared. So the answer to the questions is for A, area of the stadium in terms of diameter is equal to 1,000 minus pi times diameter divided by 2 times diameter plus pi times diameter divided by 2 squared. That is the equation for the area of the stadium. And for step B, what is the maximum area that the stadium can be? The maximum area is 79,577.47 feet squared, and the diameter when the stadium is at maximum area will be 318.31 feet. For step 3, what is the length of the diameter when the area of the stadium is at least 60,000 feet? The diameter will either be 476.2 feet or it will be equal to 160.43 feet. Thank you for listening to our presentation. I hope you understand how to do the problem.